All right, good morning or good afternoon, everyone. Uh, Today the class will be virtual. I'm traveling outside the city where I live. That's what I'm doing online class. Um, Let me go ahead and talk about what we are going to learn today. One second, let me pull up the slides. All right, today last class we talked about system calls, um, and we've gone through how to um, make a system call using interrupt int 0x80 in 32-bit system and syscall in 64-bit system. Okay. Now today we'll talk about concept of process, basically how what is process, uh, then how many processes you can create uh, in your user space, region. When we are talking about operating system, we have kernel space and user space, also known as kernel land and user land. Okay, then how to switch from user land to kernel land? There is an interface which called system calls. User level programs use syscall to you know ask kernel what they are trying to do. Okay, and let me quickly show you some of the programs how they use syscall. Okay, and there are a couple of programs we can use. uh, there are syscall, strace, and ltrace. There are two programs you can use to trace the system call. Okay, now that's the concept on how system calls are being used from user level program. Now, when we are talking about user level programs, we have multiple programs. Okay, for example, we have email client. For example, we have command line, and also let me show you example in Windows. If you go to CMD in Windows, what will happen? you know, you got the command prompt. Okay. Now, if you write some system, let me do help. And these are the programs you can run. If you do Word, it will show you the version. Okay. Version of your operating system. If you do title, you can set the title. Let's say title um, demo. If you see the title changed to demo, here you go. Okay. Now, these are the user level programs. Now, when you run these programs, what will happen, how your operating system manages these programs. For example, I'm running Notepad right now. What's happening, what it is? Okay, Notepad is an application you install on your machine, or you write a program, then you create an executable or binary programs specific to your architecture, your operating system, maybe Windows, maybe Linux, and whatnot. Okay. Now, today we'll talk about how these programs works, how operating system manages when these programs runs. When we run these programs from command line, or when you develop a program, you know, let's say for example, if I run Python, okay, it's going to run in my machines. Python is a program, okay. Now, in this modules, we'll talk about how operating system manages these programs when they are in execution. That's the idea. That's the concept today we'll talk about. Okay. And this is all about processes. This is called processes. What is a process? You know, process is entity, or process is something going to, you know, uh, managed by your operating system kernel when you run a program. Any program you can think of, that has to be a process to get executed. What that means, as I mentioned in the last module or last class, when you're talking about a program, we have two, high level two component in the program. We have code and we have data. Okay. Then when you run program, what will happen? You have to load that instruction and you have to load that data. Then when you load instruction, who will execute your instruction? Basically, CPU needs to execute your instruction and it has to access the data. Based on this concept, what is the process? Program in the running state. When you run the programs, then program needs code and data. That's whole state or whole instance of the program is called process. That's what process is. Okay, that's what we are going to talk today. All right. Now I'm going to use slide from Silverstad's book, 10th edition. I think I send you a link how to access these slides. Okay. As I mentioned, today we'll talk about concept of process, basically what it does. We'll talk about. Let me get the pen highlighter. Perfect. Okay. As I mentioned, today we'll talk about process concept. What is process? And we don't run single process, yes, we run multiple processes. Then as an operating system, okay, operating system is a resource manager, or operating system is a virtual machine manager. You can think that way. Then operating system has to manage resources. When you're talking about resources, we have CPU as a resource, we have memory as a resource, we have input output devices as a resource, we have storage as a resource. Then when these processes wants to run, they need to access these resources. Then at a time, we cannot run hundreds of processes. Then CPU need to, do some type of scheduling, or it need to prioritize which process it will execute. That's called process scheduling. Okay. Then after that, we'll talk about operations on process. What are the operations we can do? And also we'll talk about how this process communicates, inter-process communication. Okay. And I'll show you some examples also. Then we'll talk about IPC, inter-process communication using shared memory system. How these programs use shared memory. You can think of it as a shared location between multiple processes, and they can use this shared location to communicate with each other. That's the idea. Then also inter-process communication in message passing system, and we'll go through some examples. And also we'll go to client server system. That's the basic mechanics. All right. Now let's continue. One second. Let me close this pen. Perfect. Now, objective. Hold on. Yeah, okay. Now, the main objective, let me move this video a little bit up. The main objective will identify the component of process. Like when you're talking about process, and we will go a specific process, and what are the components of the process, okay? Then how these components are represented and scheduled in an operating system, okay? And we'll talk about how processes are created and terminated in the operating system, okay? We'll talk about, system calls, if you remember, appropriate system calls and the operation they perform. When you're running some programs, it has to use the system call. Why? System call is an interface. That's how your program going to access resources through the kernel. Okay. And we'll talk about, we'll differentiate between inter-process communication using shared memory and message passing. These are the two techniques supported by operating system when multiple processes communicating each other. Then we'll compare them. And there is a concept of pipes in Linux. We'll talk about pipes. And POSIX is a compliant or is a standard is going to use shared memory when we are talking about performing inter-process communication. And we'll talk about client-server architecture using sockets. What are sockets? Sockets is basically a data structure provided by operating system, which is going to implement in the kernel space. And socket constitute of IP address and port number. You will uniquely identify a specific service running on your machine. And we'll talk about RPC, which is remote procedure calls. It's a common technique to communicate multiple processes, maybe distributed systems, maybe, processes running over the network, whatnot. And we'll talk about how kernel modules interact in the Linux operating system. If you remember, kernel is a monolithic architecture. Linux kernel is a monolithic architecture, and it uses, modules to extend its functionality. That's what it does. All right. Now, process concept. I think I want to, hold on, let me clear this. Mhm. If you remember, you start seeing the concept I described earlier. All right. Now, as I mentioned, operating system executes, variety of programs that run as a process. Whatever programs you run in your operating system, it becomes a process. These are the different types of processes. Okay. And what is a process? As I mentioned earlier, a program in execution. Okay, that's the process. Then what are the parts of the process? If you remember, when you're talking about a program, okay, programs become a process when it executes. That's the idea. And what are the parts of the program? Program code. You need a code section, which is also called text section. Okay. And also we need data section. That's what we mentioned earlier, code and data. Now, when it comes to running the process, this data has to be loaded to the memory. This data has to be managed by your operating system. Okay. Then it provides program counter. What is a program counter? If you remember, I showed you EIP and RIP, also called instruction pointer. Program counter going to, hold address of the next instruction to be executed. That's the CPU register, which is one of the CPU registers. Okay, then we need a program counter. Why? We want to keep track of program execution, code execution from the program. Also, when we are running function, we need to manage local variables. We need to manage function arguments. Also, we want to manage return types. All these variables are local to the function. Yes, if you call that function, it's gone. Then then it uses stack. It uses stack to store temporary data, such as function parameters, return address, local variables, and whatnot. Okay. Then we have a data section, which is a global information, global variable. And also it has a heap component, heap section. It's going to start, it's going to, reserve for dynamically, allocation when programs runs during an execution, it may need more resources. That's what dynamic executions. All right. Now let's review it. Program is a passive, when you compile a program, it's a passive, it's on hard drive. Okay. You create executable in Windows, you create, ELF file in Linux and Mato in Mac. These are executables. These are going to be stored on your hard drive. That means these are passive. When you run a process, it's become alive, it's become active. Okay. Then when you run these programs, it has to be executable file. It has to be loaded into the memory to get CPU, to get the attention of the CPU, so that this instruction and this data will be, work together what you want to achieve. That's the idea. And even you can think about running a program in graphical user interface. You can click mouse, you can go to command line and whatnot. Okay. um, One program can be several processes. You may have multiple processes. Okay. For example, if you have a web server, when you are running web server, you need to run multiple processes. Why? Or multiple threads sometimes. Okay. Then you may have threads inside a process. We'll talk about a concept of threads. Okay. All right. Now let's continue. Now let's understand what's happening when you load your program, and that program in a memory, it's become a process. Okay. And each process has its own address space. Okay. Each process has its own address space. Let me get the pen. Okay. Each program has a range of memory starting from 0 to max. It's a you can think of, it's a size of memory allocated to each process. Whatever the process you run, this process get memory of size max. Think about that. And this memory contains text, which is, we know, code section, and it needs data. Okay. Why we need data? That's what program is. It's going to take data. It's going to take data from the user, such as going to load some configuration files. Sometimes it may load data from the command line and whatnot. All right. And also we need heap and stack. I mentioned you why we need stack. Stack is going to use to manage execution of the functions, manage local variables, manage, we pass arguments to the function. Okay. And we want to keep track of return address. That's where stack is used. And heap is used to manage dynamic memory. All right. Now let's take this an example. Okay. And now this is a simple program, C program. What it does, it uses malloc, to allocate some memory space, and it goes through the for loop, and it assigns that variable to that memory locations. Now, how these programs map to the memory? And if you look at this, is the text section. This is initialized data, int x and y. Okay, y is initialized data, and x is uninitialized data. Okay, then stack is going to use to store these local variables for main function. Okay, and heap is used for malloc. It's a dynamic memory. And also we have arguments for main function. These are going to store here. Okay, this is how the program you wrote map to the memory. All right. Now we talked about process. Now we know high level process. What are the components it has? And you may be thinking, is there any way we can see? Yes, we can see all these components. Okay. Now, when we create a process, there are multiple states each process has. Okay. And I think you've gone through this concept in your undergraduate operating system. If you are coming from computer engineering background, if you are not, this may be new concept to you, but let me go ahead and explain it. Okay. When we run a programs, this process has multiple states. Okay. you know if you try to run a program, it's creating first time, it's going to be a new, it's still going to be a new. It's going to be in the queue. You can think of, let's say you go to the restaurant or bank account, your bank, to deposit a money or something. You will be on the line. Yes, that's the new customer, they are coming, but they are not served at. That's what they are not running, they are not on the counter. they are not executing. Then when it's running, you will get time from CPU. That's what running is. Okay. Now, when you are running, you will not get all the CPU time. What will happen? CPU will schedule this process. Let's say you need some input output or you want to communicate over the network. Then that process will be in the waiting queue. Then it will serve another process. Okay. Then when process is ready, completed other tasks, and it will be in the ready state, and CPU will pick this process from ready state. And once it's done, it terminates. These are the some states. And I'll show you example also, don't worry. All right. Now this is diagram, what will happen. And new process gets admitted to ready queue and it's running, interrupted back. It's on the ready queue if you think about here. And also sometimes, when it's running, input output event happen, it's in waiting, and CPU scheduler will dispatch this to the ready. And you can think of ready as a queue of processes that are ready to get executed. All right. And once done, it's exit. Perfect. Now you may be thinking like how this process is going to be managed by operating system. Yes. Then there is a data structure called process control block, also called task control block. Okay, it's going to state information about process. All right, it's called process control block, PCB. And same, if you remember, we'll talk about inode in file system. But inode is a data structure which is used to manage or used to track the file's information. What's the size? Who owns the file? Who created? The same way, process control block is going to store information about process. And what are the informations? You know, Process state we need to keep track of. And I will show you in real example also how this data structure looks like. In CPU registers, scheduling information, is it high priority or not? And memory information, okay, and accounting information like how much CPU is used, whatnot. And IO, is there any IO allocated to this process, or how many file you open? And if you run process by default, there are 3 file open file associated with each processor. It's called default file descriptors. This has value 0, 1, 2. What that means? Input, output, and error. These are the 3 descriptors or open file attached to each process. And I'll show you an example of that one. Process now thread. What is thread? What the heck thread is? Okay. So far, each process has single thread of execution. If you have a main program, you run that process as a single program. Boom. Now, what if we have a multiple program counters per process? Multiple location can execute at once. Then we need, multiple places. It's going to execute same code. Then what we need a thread. It's the same code, a same program, but we are running in multiple places or multiple, instances. Then thread need to store, same way we are tracking process, we have to track thread as well. And we need multiple program counters in PCB. All right. Now we'll talk about thread in chapter 4 detail. Now focus on the process, this one. Now in Linux, this process is, represented by task underscore struct. Task underscore struct is a data structure. It's going to use as a process control block. That's how process represented in Linux. All right. I can show you all of these. Okay. Now, right now we are showing some critical piece of information, based on our previous discussion. But we can clearly go to, let me go ahead and hold on. We are here. Let me go to my GitHub and I will show you to explore that one. Let's go to operating system. Go to Linux, kernel, and we want task underscore struct. Let me find where is that. Task underscore struct. CPU. I'm just trying to find that one. Modern task underscore struct. Okay. Now let me go to kernel source code. Control C. Uh, Control V. If you go to kernel source code, then we want to find task underscore struct. And then include Linux fs.h. Control F, fs.h. Okay, let me go to. I am just trying to find. Okay, I think that's the earlier one. Click here. Let me load that file while it's loading. This is there anyway. I can quickly find. Process.h. Okay. Now task underscore HTML. Yeah, this is structure. Let me click here, and it will show you where this is. Defined as a structure. You can go here, and where these are reference. Let me go to schedule.h. Now this is the task underscore struct. If you remember, we can see some of the information we mentioned earlier. Uh, if you look at here, this structure is defined from here. Okay, it is a task underscore struct. And it needs thread info. Within a process, we need a thread info. And state, if you remember, that's the process state. Okay. Then what we talked about, yes, just earlier. mm, uh, Memory structure. It's going to use memory. It's going to use memory structure and an open file, if you remember. This is the structure Linux uses to manage the processes, and it also use you know linked list is heavily used in the Linux kernel. And if you remember anyone taking data structure and algorithm, you get a chance to learn lists like singly linked list, doubly linked list, um, you know, circular linked list, circuit, doubly circular and whatnot. That's you can see how kernel is using that. Okay, this is whole task struct. If you look, it's a huge structure. It's a huge structure. Let's see up to here. Yeah, you got the idea. That's the task on disk struct. You can look here and find out, where it is used. All right. Now, we know about process and how Linux manages these processes. I want to show you an example. But right now, let me stop here. And before moving to process scheduling, I will show you how you create a process and how you check each sections and how you validate. Okay. That's I'm going to provide in the next video lecture.